MPI. So just to give an idea, I'll finish by time. Don't worry. So what do you know? What do we need to know? That what are the different amount of processors available? So we have to keep on grouping them. And the by default group will be your MPI underscore com underscore world. And these groups are called communicators. So only the processor belongs to a group can communicate among themselves, other cannot communicate, which doesn't belong to the same group or communicator. Similar way, same processor can belong to more than one group. And you can make multiple groups depending on the need of the processor, that how many processor you want to get involved for this computation purpose. So just giving lot many processors will not do the work. So this will be called communicators. Now, MPI routines means the libraries that we required to do this kind of programming. So we require additional set of functions which are not readily available in our C or C++. And for example, we will be following C only for writing the programs, but with additional features that we require that are available in MPI header file with the library functions. So what kind of need we have? We require to have some kind of communication mechanism between the two processors or among all the processors or among few processors. We may require to have different kind of process management group functions to schedule the processes accordingly and whom to assign which job, when to assign, when not to assign, or something like that. And the different kind of data types also. And how this processor to be configured topologically. For that, we require some additional function and some miscellaneous function for other management purpose. So I will not discuss all this, but you can just see that there is different kind of functions that are readily available. These are for only writing parallel programs. So what is the general structure of a program? And it's a C, and almost you all know C nowadays, because irrespective of any scientific department, everyone has a kind of programming language like C or something. So it's like a traditional program, but what additional thing that we have to include the header file mpi.h that is dedicated for these parallel routines or libraries to be used for writing parallel programs. Others is like the main function in C, and you have to initialize the MPI environment before starting the parallel part of job, and you have to terminate that MPI environment after finishing the parallel part of the job. The sequential part may be above initialization of MPI environment or after finalization of the MPI environment. And we have two functions. For initialization, we have MPI underscore init, and for finalization MPI underscore finalize. So that way, using some these functions, we can write the parallel programs in C for these parallel systems. Now, suppose this is the simplest program we are having, and we are following SPMD model. Like this program will be in your memory, in my memory, in someone else's memory. So this same program will be executed by you also, me also, or someone else also. And we all belongs to the same communicator group. So each and everyone will print hello. And that is given. How do you understand that this is a parallel part? Because this printf function is within MPI underscore init and within MPI underscore finalize. By doing, after invoking that function init, it will do the MPI initialization in parallel mode. Then after that, whatever the instruction will get in parallel mode, after finalize, that will come to sequential mode again. So what will be the output almost? If we try to execute this with 3 processor and see that commands for compilation varies from compiler to compiler. In GCC compiler in Linux, generally MPICC is the command used to compile the parallel program, and to run MPI run, and with that specifier you have to tell with how many processors you want to get execute this. So if I run this program with 3 processors, there will be 3 hello. If we try to run with 5 processors, sorry, here it will be 5, then it will be 5 hellos, depending on how many processors you are having in your system. So just to give that how within the same program, 2 person can do 2 different things. It's nothing but within the communicator, each processor will get an unique identifier that you have to identify yourself by this kind of functions. Then based on that, if my rank means sub my ID is equal to 0, then I'll do some job. Like here I am, it's printing that I am master and my rank is this or that. Or others will do the other jobs. So each and every one belonging to the communicator will have their rank starting from 0 to n minus 1 if there are n number of processors. And by this ID, you can segregate within the same program which part to be executed by me and which part to be executed by you, or which part to be executed by whom else. So that way the SPMD model works, that the same program will be in all memories, will get executed by all the processors, but each and every one will execute different part of the programs. So if we run this program with this, with 3 processors, it may come like this, the outputs. So from this programming point of view, I'm not going to discuss this because you may not get interest on this, but to just show you that okay, this way programs are written in small examples. This is not real life examples. Okay. So what we come to know, and to write parallel programs for the GPU architecture, we use CUDA that was invented by NVIDIA. Fine. So I'm not going to discuss this. To finish up, what is the summary? That there are a large number of emerging applications that demand huge computational power. Parallel computers are designed to perform optimally. Not all the computers are parallel computers. Neither all the problems are parallel in nature. There are some problems which are sequential in nature. You cannot apply parallelism, and if you apply that same program, you will not achieve the performance. Parallel application need to be developed using parallel programming language and approach only. Neither parallel program will give better performance on a sequential computer, not sequential program will give better result in parallel computer. Hence, parallel application will give the best performance on parallel computers. So this is the kind of problem we are having, that we bring any program and try to execute on the parallel machine, HPG system, and we shout that why we are not getting the speed up. Because the program may be sequential in nature. So any program, if you try to run in HPG system and you expect that it will give you better result, no. You have to rewrite your programs in parallel mode, then only the parallel system will work. Otherwise, what will happen? Out of n number of processors available in the system, but only one will do the work. And only one with n number of processors, and having only one itself is of no difference, because all the others are remaining idle. So different applications have their different architectural demands. So we cannot say even like I have purchased this parallel computer, so it will work best for this application. So again, it will work best for the other applications. No, for each and every applications, as their demands are different. So we cannot say like you purchase a regular t-shirt and it will fit to each and everybody. Depending on the nature, you have to write the program differently. You have to use the different parallel computers with different architectures. And obviously, you need to write in parallel mode. Don't expect that you have a sequential program, you execute in parallel machine means that it will give you a huge number of performance effort. No. Even it's not the case that when you are going to write a program to solve a large problem, okay, or small problem, you write forcefully in parallel and you think that, okay, it will give best performance. No. Forcefully, if you write a sequential program to be in parallel, what will happen? For 1 second computation, the data has to travel 5 minutes. So the traveling time of the data movement between one processor to another processor will take much more time. Instead of that, you could have been executed that with lesser time with single processor. So we need to understand the ideas so that we can know that how the program should be written in parallel mode. It's a very brief idea. Okay, lot many technicalities are inside there. I try to skip to finish within the scheduled time. So there are some references, and thank you for your kind hearing.